from an AI. And while you would basically see those terminologies and technologies, you will be able to relate what exactly I'm talking about. Okay. Now, now this presentation was not meant to be a PPT, because in general PPT you should have short and sweet, and basically you just have a bullet points. But I don't want it to go this thing like a corporate presentation. I basically want this thing to be more academic.
Tawfiq, could you unmute yourself?
Someone muted me.
Yep, yep, sorry. That was me.
Okay. I mean, don't do that, bro. Okay. All right. So this is the thing, right? Now, first thing is, let's understand from the AI part, right? Let's understand what AI is, right? Now, for every slide or every technology or terminology which will be going, I'll give you an analogy for you so that it basically you understand in a way you should be understood it, right? Now, one thing is, guys, you need to understand that AI is fundamentally reshaping everything what we do, right? The way we work, the way we do business, the way right, companies work, the way computers work, right? Everything is being changed, right? Now, at a time it used to be like a fictional thing, but now it's no more a fiction, right? You can see things, magic happening just, right, I mean, in front of you, when you basically ask something to chat GPT, right? When you build something, a picture, or when you basically do a lot of editing in your photos, you can see the magic happening, right? And this is something which was a fiction at one point of time, right? Now, if you look at, people are using the tools and platform, and that is how businesses operate, and this is how professionals are working right now, right? So what we will do is, we will basically build up a real company, right? Something, what a company, what we can calling a tech corp, but we'll build with a sophisticated AI system, right? By the end of the day, right? By the end of this 1 hour, our company will go from zero AI to fully backed up AI system, right? Now that is what we'll do. I'll just give you an example that how are we gonna build this thing, right? Now imagine, right? For example, even if I take a step back, right? Imagine that you're running a small company, right? Uh, for example, right? I mean, this is a Hyderabadi company where you are, right, being employed. You're employing 50 to 100 people, and they're using a, a lot of different systems, right? So they're using Excel, they're using PowerPoint, they're using, right, the application documentation processing systems, right, so on and so forth, right? Now, when a new employee joins, right? I'm just giving you one example. When a new employees join, instead of, right, going through the company policy, that what is his leave policy, right, how many days leaves can he take per month or per year, instead of going through documentation and spending 30 to 60 or 90 or maybe even more than 90 minutes, what if it just says, can you tell me what is the vacation or a leave policy in my company, right? And within 10 seconds you get an answer, right? Imagine that's the level of right, AI work what we are doing behind the scene now, right? So always think of AI like this, right? Think of an AI as a brilliant personal assistant, okay, who can basically read, remember everything about your company, and then depending upon your question can give instant answer to any question what you want, 24/7, right, without even getting tired, without even forgetting anything. Yeah. So that is something what we are looking at, right? Now whenever people ask you about AI, excuse me, so you have to, in a layman language, it's about thinking about a brilliant personal assistant, right? Now over the time, right, this is not about abstract theory anymore, it's practical. It's a deployable technology. So whatever I said to just now a minute ago, that I wanted to build this Hyderabadi company, right, where a new employee comes in, okay, and straight away gets answer by reading the documentation what the company has got over the years, okay, in 1 second, in 10 seconds, right, without going through the documentation. Now that has become a reality today, right? That has become a deployable technology today, which we can basically take advantage of. And imagine, right, what could be the possibilities, right? So this is one, right? Now, on a very high level, we just talk about company, we talk about search, we talk about asking a question, we talk about AI giving back the answers. Now, this is something even a 5-year-old or 6-year-old guy would basically explain or understand, right? Now, what we as technology enthusiasts, right, we wanted to understand how things will work and how we can connect this dots together, or how we can brick them so that, right, I mean, Lego them so that we have this complete architecture in place. Okay, now why is AI feels so confusing, right? Now the problem with the thing is, on a very high level, we basically we got used to Chat GPT. We know that Chat GPT has become a new norm right now. Instead of doing a Google search, we open up at Chat GPT. We say, "Hey, tell me when is the birthday of Shah Rukh Khan," and then Chat GPT says, "Hey, you're right. It was like a week ago, and this is what things are happening. This is what he does when his birthday. Blah 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 blah." So you don't ask anything. You don't go to the Google. You don't go to the Wikipedia, or you don't do, right, 10 different steps, right? You straight away get the answer what you're looking for, right? Now the buzzwords with AI is very confusing even today, right? People talk about large language models, people talk about embeddings, people talk about RAG, people talk about vector databases, lang chain, transformers, fine tuning, prompt engineering, blah blah blah, right? Now all of these things are connected to each other, right? And that is what, right, I mean, when you read in every article on AI, you would basically see that the author who's writing that article, he basically assumes that you already know the basics, which may not be the case, right? So every tutorial which you learn today on AI, they skip the why part and they straight away jump into the how part, right? And that is where we see the biggest gap, right? The missing context. You hear about it individual pieces, but you never see how they fit to each other. Okay, now for this I basically give uh, a car analogy, right? So I say, like, think AI as a car. AI is a car, like the whole AI is a car, right? Now the car have different parts, right? And so does the AI has got. So the large language model, or LLM, right, is the engine that provides the power. Okay, the embeddings, right, and we'll go through embeddings in a bit, right? They are like the GPS that understands the location where the car is going, or which direction the car is going. The vector databases, right? And now we'll going through this detail about what vector databases are. The vector databases are like a fuel tank, which stores your fuel or the storing energy, right? The lang chain. Now, all of these things, write it down somewhere, and maybe tomorrow when you're explaining to someone, you'll understand it. The lang chain is the steering in the wheel that controls everything, right? Now, all of this part is essential, and they don't work in silos, right? And that's where, right, when people have this buzzword, they basically, when someone just says embeddings, they do, oh, what's embeddings, right? Or what is lang chain, or what is lang graph, or what is LLM, right? Now when you know the car analogy, you would basically be able to understand this thing in a much better way, right? And that's what today we're going to demystify these concepts by building a piece by piece, right? Show you exactly how they're connected and why each of these components matters, and give you the clarity, instead of confusing you, right? So that is something what we will do today over next few minutes.
Tofik,
Okay,
can you please go back and explain the car analogy once again?
someone had a question, or it is coming from you?
Coming from me.
Okay, so the car analogy, okay, so again, it's like this, Samir, right? I mean, when we talk about artificial intelligence, right? Now the AI itself AI is the whole, like for example, IT, right? IT is in general, right? Within IT, you have so many different things, right? You have compute, you have storage, you have databases, you have APIs, you have systems, you have operating system, you have network, all of these things, right? And when you say, I wanted to go into IT, if someone comes and says, Samir, I want to get into IT, right? You say, what do you mean by IT? What is IT, right? And then you'll basically say that what are the different pieces connect with IT, right? Now within AI, we're giving an analogy of car, right? Now we're telling AI itself, when we're speaking about AI itself, AI is like a car, right? The LLM, large language model, right? The large language model is basically the model which is getting be trained. Right now, this LLM, defining LLM and how LLM is working itself is an ocean, right? The large language model is the engine of the car, right? So you know, Samir, when you basically say go to the chat GPT, right? Without nowhere, you say, can you tell me when is Miladun Nabi? Right? It straight away gives you the answer, right? Now, basically, that is what the engine, right? I mean, it goes back to the LLM, and then the LLM, whether it is Chat GPT or Llama or Anthropic, and there are many different LLM or AWS Bedrock or Azure's AI. It will go to one of the LLM, right, which you're asking. The LLM is already been trained. It is trained in all of these things, right? Now you don't have to do anything. It's a trained model, and the model keeps learning. And over the time, it becomes more better and better and better, right? That is what we call LLM as an engine, right? Now embeddings, and I'll get into detail in a minute. They are basically which helps you understand the location. Now you don't have to do anything with embeddings. Okay, for example, when you basically set up an application, a three-tier application, and you have a front tier, you have a backend, and then you have a database. You don't do anything as a database, right? But you understand that the databases are there for you to take the data in and put the data out and understand how the data has been structured, right? Now embeddings and vector database work in a similar manner, right? Behind the scene, you don't have to do anything, right? But we're just trying to understand from the analogy thing. The lang chain is basically how you orchestrate things together. How is all of these vector databases, embeddings in LLM are basically being able to, right, connect. That's where the lang chain comes as a steering of that wheel, right? Now, and there are more on top of that. There's lang graph as well, right? There's a rag as well. But in a very high level, this is what we are, right, making you understand so that you would be able to connect the dots. You're clear, Samir?
Yes, Tawfiq. Thank you. I
No
hope
problem.
now everyone has a clear idea.
No, that's okay. I mean, see, guys, one more thing I'm trying to understand, right? I did not get this thing in one day, right? And even if you're not able to get what embeddings, vector databases, LML there in day one, no problem at all, right? But at least you're starting something. At least you're able to, right, get some clarity, right? It doesn't mean that straight away after this course you'll become an AI expert. That's not the motive. Neither that would practically be possible, right? But at least you would know that the buzzword is not the buzz which should keep making you right, think that AI is something a magic, right? That is the motive of today, that I don't want you to think that things are chaotic, right? I wanted to get away from the confusing mentality to a mentality where we're able to give you clarity. Okay, now without further ado, because we don't have much time, I'll just keep right, going. But at the same time, I will spend more time wherever I think it requires more details. Right now, this is a problem. Right now, we'll come back to the what problem are we going to solve? Right, the company which we said that we're going to have a fictional company, we're calling it as a tech corp. It's a medium sized company, right, with massive information, right? Because over the time, when you have a company, you'll have a lot of things, right? You have a product manual, you have an internal wiki, you have a customer support tickets, you have a compliance document, you have a vendor document, you have HR policies, you have engineering specification, you have meeting notes, you have teams, you have emails, right? You have SharePoint. You have all of these things in place to run a company, right? Now this is, and our company is no different, right? And the problem what we see in our company is that our employees, whether existing or new, they waste countless hours searching for information. Okay, that is the thing, right? That's the problem what we have today, right? And even if the new hire they join, before even they understand the company policies, which document is where is the HR policy, what engineering specification I need to follow when I'm building up an architecture, how should I basically take meeting notes, what is company security standard, right? How should I be adhere to company security policies, what is companies HR policies, all of these things, right? It takes months for a new employee to get to the speed, right? And somewhere the critical knowledge has been trapped, right? It is in silos, right? Samir has written some document in TechCorp. It is, right, lying in his folder in some SharePoint, right? Irshad has put something somewhere on his SharePoint, and he has called it as my SharePoint document about employee data, and that is somewhere else, right? So they're all in silos, right? And today we all can relate to this problem, right? I mean, in our own system, when we over the time in 10-15 years, when we keep putting our files, we'll have a folder called as learn new course, we'll have a folder called as right, I mean, health and fitness, we'll have a folder called as right, I mean, children's school fees, right? And all of these things over the time, that also could get lost, right? I mean, and then when we start finding, we'll say, okay, I remember I put up a folder somewhere where I had my right, the school fee details of my kids, but I could not find it, right? This is what the company go in and day out, right? Now what is our vision, right? With the vision is what we as a team, right, the team of career lift bootcamp today, what we wanted to do is we wanted to basically build up an AI system. We know that the TechCorp needs an AI system. What would the AI system will do? Okay, let's give that AI system proper scope, that what did we need from it, right? We want the AI to find relevant answers across all the documents. Okay, we want the AI to understand the questions in a natural language. I should not say, I should not exactly say if the company's vacation policy, right, is written as a vacation policy. And my question is, can you please tell me that what is company's holiday policy? Then the AI system should not say, I don't understand holiday, because everything, whatever it's written in the document is vacation. No, it should understand your natural language. It should connect. When a user says vacation or holiday, it means the same thing, right? That is the kind of a system we need to build in. Under the hood, AI does it by itself, right? We are not going to do anything different. We're just going to basically connect the dots. We're going to use the existing system and build together so that we build up that AI system for TechCorp, right? We're going to automate the repetitive task, like routing the support tickets. We're going to make sense of the pattern of the data, what the company has got. And we basically going to tell that AI system, keep learning, keep improving, keep learning, keep improving, right? Because we know that AI patterns, right, right, they get better by training themselves with the data, what we feed them, or with the way we train the data, right? Now imagine you're typing it, what's our refund policy for enterprise customer? Because this is a company which does sales, right? And I'm a new sales guy who's coming in, and I just quickly wanted to say, what's a refund policy for enterprise customer, right? Because one of the customers have asked me, I'm buying a product from you, but if I don't like it, if I would say I need a refund, do you guys will give a refund, right? Now there are 50 people sitting in my room. Instead of going and asking any one of them and getting 2 or 3 different answers, I would basically get an accurate cited answer in 2 seconds instead of 20 minutes of document hunting. Okay, so far so good, guys. Sabir, any question on the chat?
No, not of it. Guys, if you have any questions regarding anything you missed out, please post it in the chat so that we can answer it whenever
Cool.
possible. Thank you.
Cool. Now let's get into right, the main core of the thing, one by one. Okay, one by one. The first thing itself, right? We need to understand what LLMs are. Large language model. Write it down straight away. If you have a pen and paper, if you have a computer, write it down. Right. Don't write anything else, but write it down LLM. And after that, when you finish this thing, you'll able to understand what exactly I'm saying, right? Now, LLM, we don't have to understand it in detail, right? That is like a 8 year or 10 year course itself, that how LLM work or how I should develop an LLM, right? Just think of it's a neural network trained on a massive amounts of text data, okay, which can generate and understand a human-like language with a remarkable sophistication. That's all. That's all, right? That's all. And one of the example of LLMs is ChatGPT, right? Now, if you guys know Claude, if you guys know Llama, if you guys know AWS Bedrock, which is good, but understand that there are more than one LLMs, and right? And at the moment, as we are speaking, the market leader is OpenAI's ChatGPT or GPT. Okay, now, right now, this is what LLMs does, right? But LLM, when we basically ask anything to an LLM, right? What we need to understand is one crucial limitation that shapes that what we understand about LLM is context window. Now, write it down. Write it down as context window, right? We saw LLM. Write it down context window. Now, context window, I'm going to tell you in very, very simple and plain English. Context window is a short-term memory of an AI model. Right? For example, I may have memorized, right, 10 surahs in Quran. Okay. Ruqayya would have memorized 50 surahs. Samir would have memorized 100 surahs, right? Now, if you ask me about, right, can you recite something on Quran, I would basically only give you whatever I have learned and memorized. Samir will give you little more. Ruqayya will give you more than that, right? Now, context window is basically a short time memory of an AI model. That's the keyword, right? That's what that means is it's how much text that the model can see or remember at once, right? And how it is converted is the way it is converted is through tokens. Now, again, another word. So we got LLM, we got context window, and we're going to learn about tokens, right? Now, tokens are basically how much, right, a character is what an LLM understands or reads, right? For example, one token is roughly 3 to 4 characters, okay, per token. We don't want to learn more about it. Just think about, right? I mean, I love Hyderabad. I is a character, love is a character, Hyderabad is a character. Okay, now that's where the token thing is. It has been calculated, right? Now we have different models, right? A small model may have anywhere between 4,000 to 8,000 token, which is 3,000 to 600 word, and there is a benefit of it because if you have a smaller model, it's fast and cheap, right? You don't pay a lot for the token. At the same time, it will give you answer because it doesn't have to do a lot of searching, right? Then there is a medium model and there is a large model, right? I mean, and you could think about a small model as a small booklet, a medium model is a medium book, and a large model is book as big as a Quran, right? Something like that. Just giving an example, like an entire book, right? Now, bigger window, the AI can handle longer documents. That's all you wanted to know, right? We're not going to invent anything. We're not going to do anything with that context window. There's nothing which you can develop on context window, right? Like when I say not develop, it means like you're not basically going to write a program. Can I build like a context window model, right? I just want you to understand it, right? Now, the analogy of thing is think of a context window as a short-term memory. A small model can remember details from a current conversation, and media models can remember the whole meeting, and a large model can remember everything we discussed in a week, right? Okay, that is how you basically understand what a context windows are. So what we understood so far: large language models, context windows, tokens. All right. Okay. Now, all right. Now with the context window, like we'll still be in context window, and I want to give you more example with the context window, right? With the context window, there is a trade-off triangle, and which we explained it, right, on the previous slide, right? If you have a bigger context, which you let feed more data to the model, it will provide a richer context for the better answer, right? For example, if I have a bigger context, then for example, if I ask any question, I will get a detailed answer, right? But the same side, the trade-off is the processing speed of a larger context is longer, right? And that's where when you basically, when you give a complicated scenario to chat gpt, you see it keeps thinking, and then it say, I'm thinking for a better answer, I'm thinking for a better answer, right? And over the time, it's also consuming a lot of tokens as well, right? That's an example, right? Now I would basically give this thing as an analogy. Now again, let's give us a simple analogy, as a backpack analogy, right? Think of a context window like choosing a luggage for a trip, right? A backpack is perfect for a day hike. Today we wanted to go to um, Golconda Fort, right? With the Golconda Fort, what you will take is, will basically take some, right, light snacks, maybe, right, right, some snacks. What you take, some biscuits, some water, which is light, fast, and easy to carry, right? But when you go from Hyderabad to basically say, right, Bangalore, right? In that time, right, you'll basically take a larger uh, chunk of luggage, right? Okay. And then if you basically, maybe you'll take a suitcase or a couple of suitcases, right? But if you want to basically say you're completely moving from Hyderabad to Riyadh or Dubai, right? Then basically your luggage becomes more, right? So the key is matching the capacity to actual journey. So what do you need? That's how you define the model, right? And basically, if you look at, right, I mean, and this is where, um, right, if you look at Hugging Face, there is a site called Hugging Face. I'm sure that some of you know. Okay, see there is an AI community, right? And if you look at models, there are tens and thousands of models depending upon what you need. Right? For example, you just have to say, I need a model with just do text generation, right? Then you have a model here, right? Okay, then you got a model with Llama, you've got a model called Longcat, you've got a model with Quen, right? And then we'll go the model, you'll see, okay, this is the model, this is the thing, this is what it's been trained on, this is what the capabilities are, so on and so forth, right? And then type, it's a language model. What does it do? It does the pre-training and post-training. What are the number of parameters? 0.6 billion. What are does it got any embedding? 0.44 billion. Number of layers? 28. We don't want to get into that thing. I just wanted to understand that depending upon the size of the model and what you need, it you can basically define that with your requirement. All right. So far, so good, guys. Any questions, Samir?
No, Tawfiq, no questions.
Cool. All right. Now comes the embedding. So what we have learned so far, LLM, context window, uh, tokens. Now we are basically what we are going to understand is embeddings, right? Now embeddings, okay. Here, why first of all, before we get into thing, we need to understand anything in computers, you write it, right? From the day computers were evolved, the way computers will think it is in numbers, right? And that's what, if you remember, some of the people who are here, computer science background, they would know, right, right, the binary conversion, and they would understand bits, bytes, and all of these things, right? Because we know that, and if you come below that thing, or more one step back, then you'll basically understand uh, embedded systems, where computers basically are nothing but transistors. And then if you come one level down, transistors are nothing but as on and off thing, right? Is a zeros are one, right? But and the same thing is with embeddings, right? So we need to understand within this AI what are embeddings. Don't get so confused. Don't get confused by the names, right? Now embeddings, they're very simple. Their job is they convert the word and sentences into numbers which represent a meaning, right? For example, um, right? I mean, if I say, right? I mean, the way embeddings are being taken, it basically takes that whatever you say in the word, and it will basically match it to somewhere in a number way, right? Let me just quickly, it's got, sorry, it's a small screen. Oh. Okay, that's the thing, right? So basically, it's used for semantic search, right? It's used for recommendation and understanding the context, right? Now, this is revolutionary because it moves from beyond simple keyword matching to basically, right, in a way that embeddings understand. So when you say refund policy, right, it basically has embeddings with that word. So refund policy, return rules, money back guarantee, all of these things it will understand. So it won't just basically match word to word, but basically it will simple keyword matching it will do, and it will basically give answer with all that right, it represent with the same underlying concept, right? Even though they don't share no words in common. For example, if I say I love Hyderabadi biryani, AWS is my favorite cloud vendor, and EC2 is the virtual machine with AWS users, right? Now, when if I have that thing in a model, and if I will basically ask the model, with the embeddings behind the scene, that can you tell me, can I use EC2 with Microsoft Azure? Then it would completely ignore I love Hyderabad biryani because that's irrelevant to it, right? But it will basically come and say I asked something pertaining to AWS and EC2, and it will give an answer. No, no, no. EC2 virtual machine is a terminology for AWS cloud computing, not for Azure. Azure will have its own virtual machine called as Azure VM, right? Now that is basically how things are, right, read by AI, or in general how it's been done, right? So embeddings are used for a semantic search, right, and it represents numbers that represents the meaning of the letter or the meaning of the word, right? That's embeddings, right? So what we understand it so far is, and you don't have to do anything. This is all been done, right? You're not basically doing anything, right? I'm just giving you how things are working under the hood or behind the scene. LLM, context window, token, embeddings. Now we know all of these things, how they connected to each other. Okay, now comes another critical part as vector databases. Now, okay, so far what we've understood is, right, I mean, embeddings is there. It's basically matches the pattern and gives you, right, the result, which is converts, right, your sentences into numbers. We got context window. We know what the limitation of the context windows are. We understood what tokens are with respect to the context window. We understood what LLMs are, and now comes the vector databases, right? Now vector databases are very simple, right? Now you will hear a lot about vector databases. You would have heard about Pinecone, VWhite, Milvus, and all of these things are some form or another vector databases, right, popular vector databases options available, right? Now if you look at vector databases, don't get panic, right? Don't get oh, it's another buzzword, right? Very, very simple. Vector databases are nothing a storage system for the embedding system embeddings which we just spoke about, right? Now embeddings are basically matching something, right? So they'll have I love biryani. There is an embedding for I, there is an embedding for love, and there is an embedding for biryani, right? Now where is this thing get go to store? It's not going to have magically embeddings don't come, right? They didn't come. There's no wahi come has come for embeddings, right? So these embeddings are basically being stored in something called as the vector databases. Okay, it lets AI search by meaning, not just by exact words. That is where vector databases is there, right? It searches by meaning, right? That's why when you give in chat GPT, tell me what is the best way to prepare Hyderabadi biryani with the spices available in Australia, it won't go one by one. It basically will search by meaning, not just by exact words, right? And this is where vector databases they come into place. just like your relational databases where you stored your, right, your banking details, RDBMS, right, or relational databases method what you use, or just like a NoSQL where you have a NoSQL way like MongoDB, or right, any other databases. Vector databases are basically databases for AI. That's all you need to know, right? When you search a vector database, you're not looking for exact matches. Unlike in a traditional databases, you say, can you tell me that at HDFC, right, in HDFC Bank, last 3 months, what did I do in um, Hyderabad Central Shopping? It will give you the statement, right? It has to give you exactly the statement because that's a banking data. It won't, even 1 cent or even 1 paisa should not go from here and there. It should give you the clarity. But here, vector databases, the way it has been done is you're looking for exact matches, right? So when you find a similar vectors for a query embedding, it's ranked, right? So, and I gave you an example of I love biryani. AWS is my favorite cloud provider, and EC2 is the way AWS is having its virtual machine being deployed, right? That's how it's basically been connected, right? So what we understood so far: LLM, context window, token, embeddings, vector databases, right? Now, in a way, we're able to basically understand things in a level, right? I mean, in a way that how AI is basically gonna keep this architecture in place. Now for this vector databases, the analogy which I'll say is, imagine a library, right, where books are not organized by an author or a theme, right? In generally, if you go a library, you may have a bookshelf by, right, I mean, I don't know, Mirza Ghalib, one set of poetry books, right, uh, Shakespeare, one set of novels. I don't know, right? I mean, Pandit Jawaharlal Nehru's books, one set, right? So they are basically organized by the title or an author, right? But the way vector database does is, it basically aligns book like, say, leadership, and all the books pertaining to the leadership will cluster together. Okay, food, all the books pertaining to food, whether it's Chinese biryani, right, Japanese sushi, all of these things are together, right? That's vector database, organized by semantic similarity, right? Not in alphabetical order, right? That is the analogy what I give when I talk about vector databases. So far, context window, tokens, embeddings, LLM, vector databases, right? The core element is, this is how the core elements are. Okay, now now we'll just go one level above all of these things, right? Now the thing what you're seeing on the screen, it's called retrieval augmented generation, or RAG. Somewhere or another in your YouTube search history or in YouTube recommendation, you'll keep seeing a lot of people talking about RAG. Whenever you have an AI tutorial, you're learning something, they'll say RAG, right? Now RAG is basically, in one word, it is nothing. So far, whatever we have learned, we connect all of these things together, and that's where the RAG thing comes into place, right? And now you will love it when I'll explain it to you, right? So we have LLMs that understand and generate the text, but they have a limited memory, right? We have vector database that can store and search unlimited information, but it cannot generate answers by its own, right? Now RAG, which is retrieval, now there's three words to it, right? And that is the exactly the how it, what it means: retrieval augmented generation. Okay, RAG, it's an architectural way to combine all of these things with something powerful, right? For example, I'll just give you an example, right? Now RAG works in two phases, right? A user asks questions: what's our enterprise refund policy? The question is converted into embedding vector. It goes to it is converted into embedding vector. The vector databases searches for similar documents lying somewhere in the chunks, right? Now the top three relevant chunks which are retrieved with the sources, that's been taken, right? Now the top three are being taken, right? But what am I going to do with the top three? That's where the generation parts will come. Now all of these things, the retrieved thing, whatever I have taken, this will be sent to large language model, right? And then LLM will generate a one single answer. Okay, and it'll tell you, yes, the enterprise refund policy is this, right? So see the beauty thing, because so far you've been just dealing with chat gpt, you're not connected chat gpt to your enterprise. Now rag will basically work on your enterprise or your company, right? So it will basically go step by step procession. It will retrieve, and then it will do an augmented generation, right? And to make you understand in more beautiful way, sorry guys. So to understand is more beautiful way, it's like step by step. It's like the user query, what warranty does we cover? Then it's go to embedded query, which converts question into a vector representation. Then the vector searches, which finds a top matching. Then comes the combined query for retrieve documents. Then the magic, what LLM just is with the right answer, right? Now that is what RAG is all about. From the analogy point of view, RAG is basically like taking as a closed book exam, right? And like with ChatGPT, when you answer, it is open book exam, right? So they only use what they memorized during your training. So RAG is like an open book exam. The AI can look up the fact, right, before answering. This means your answers are more accurate. So unlike asking ChatGPT about something, and and it sometimes search throws hallucinations. Right now, I'll maybe hallucination is a topic for another day. But there are, if you openly ask something about any topic, there are chances that ChatGPT would come up with a made up answer, right? And that is what we call as hallucinations, right? But with RAG, it is basically, right, more accurate. It's more verifiable, and that is basically there. It is getting because it has understood your company's data. Okay, so again, LLM, context window, tokens, embeddings, vector databases, RAG. Okay, so much of information, alhamdulillah, in so little time, right? And we know, and we know how they're connected to each other. All right, now comes the more beautiful part, right? It's called lang chain, right? Now lang chain is nothing but, when you look at all of these things, right? RAG, vector databases, and all of these things, lang chain is nothing for any system. When you come up, right, I mean, people who are this from the programming background, when they use a database, they know that they follow a framework to deploy the database. When they use a software, a developer software, they use SDLC, right, software development lifecycle, right? When they go and do a project management, they either use a PMI framework or a Prince2 framework for how a project management method, which I'm going to use, or maybe agile technologies, right, or agile way of project management, right? Now a lang chain is basically a way that it glues all of the AI system together. Okay, so in short, what it does is it's a framework for building AI apps easily, right? So you, without going and you have a vector databases, you have understood embeddings, you know which LLM model you need to take place. All of these things there, instead of you building all of these things together and using like months and years of your time, RAG basically does not let you to build from the scratch. That means you don't have to write 100 lines of a boiler when I say boiler plate code, that means you don't have to do from the scratch. Connecting to different LLM APIs, managing embeddings, querying databases of vector, handling error, parsing outputs, all of this thing is taken by LangChain. So LangChain is basically, it will help you glue all the system together so that you don't have to do things from the start, right? You can think of this thing as an API for all the system, right? It's an open source framework. It doesn't owned by anyone. So basically you download that framework, and if you look at, right, I mean, for example, I'll show you, right? See, this is LangChain, right? Where basically what it does is you go here, we quickly, you start from, you can start building agents from here, right? You get started, okay? The first thing it will ask you, okay, this is the thing. you need to install this lang chain, you need to have Python 3.1. Okay, and if you give, I'll give you an example like this. See here, see, okay. So without lang chain, I may have to basically import everything manually and I have to build everything, right? With LangChain, I'm sorry for the size. With LangChain, I just need to call everything, right? From call OpenAI, call embeddings from here, call for vector database, use Pinecone, one of the vector databases example, right? From RAG, use RAG chain, blah, 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 blah. All you need to call it that function or call that module and it's done, right? And if you need to know more about it, you understand this thing. And if it's written here, see the core benefit is a standard model interface, right? Different providers have unique APIs for interacting with models, including blah, blah, blah. This is how it's easy to use, highly efficient agent. It's built upon land graph and we'll get into a detail and then you can get started, right? If you need to understand it more, sorry. You can go by one and start learning it, right? So we learned about semantic search, we heard about RAG agents. If you go here and then it'll tell you, okay, this is the thing, a RAG agent executes search as a simple tool. This is the thing. This is how I'm going to do indexing, retrieval and generation, right? And if you wanted to set up a RAG, then follow this method. Okay, right? Cool. We are over the time, guys. If it's okay, if I can just take 10-15 minutes of your time more, everyone is okay, Samir?
Yes, Tawfiq, yeah, hopefully.
Cool. All right. Okay, cool. All right. Now the next thing is, so what did we learn so far? Again, I'm going to repeat that thing. LLMs, tokens, embeddings, vector databases, RAG, LangChain, right? Now, LangGraph is basically another orchestration on top of LangChain. Okay. Now, with LangChain, you have to go things step by step. Okay. So you have to tell, right? Go step one, then go to step two, then go to step three. That's how LangChain is built, right? So LangChains are powerful, but they're linear. Okay. Step A leads to step B, step leads to step C, right? But let's say in our system, right, we wanted our system, the way we are building our AI automation for TechCorp, we wanted it to have a more conditional logic, more loops, more branches. For example, if I need to basically classify incoming ticket, which has got a technical, billing, and general. So I will say if the ticket is technical, go to the search engineering documents. If it's billing, go to finance policies. If it's a general, then look for FAQ document, right? Then I'll say go to then I will say if you have done all of these things in node 1, then go to the node 2, which is basically to generate the initial response. Once you have generated the initial response, then go to node 3, then evaluate your response quality. And once you understand the response quality is much better, then if you have more confidence, which is more than 90%, then send response. If you're not confident, then escalate it to human review. Right? Not everything what comes from an LLM has to be 100% correct, right? And that is where there's a terminology in AI or in general world, it's called man in the loop, right? So that means if there is a critical answer which I'm going to give to my customer, I would basically take the help of AI, but then I would go through and say, okay, this is what it says. It is 100% correct. I'm ready to send. Or maybe I'll have to make some changes here and there, right? Now, difference between a lang graph and lang chain is more linear. So it basically goes step by step. A lang graph is where you have an if and else statement, right? So if it will basically, instead of, right, going to straight away node 1, node 2, and node 3, like what we have seen in lang graph, oh sorry, lang chain, here there would be a lot of, right, if and else condition done, right? So that's how we basically know the important of lang graph. And for the tech TechCorp, what we are working on, a land graph enables sophisticated workflows, right? Now imagine if I have this kind of workflow in place, then it will my system would be in a way being made that whatever query comes in, it will be routed accordingly depending upon what that query is being asked for. Okay. Cool. Now, this is another thing, right? One, or maybe I would say the last component for us, and the most important of all. And you guys have heard this thing a lot these days. It's called MCP, right? Now, MCP is nothing but a universal plug system, right? So you have your company, right? Now, beside your company, you have your partner's company, which has got data on his company, and you have some of the APIs which has needs to come from cloud systems, and then you have another company which handles a different business unit in Dubai, right? TechCorp is based out of Hyderabad, right? Now MCP is basically a universal plug system for AI tools, right? So instead of you basically, right, working in silos and saying that, right, I would only get answer from my system. AI systems can read documents and generate text, but they can't act. They can't do by themselves. They say, okay, no problem. I don't understand from your system. Maybe you would have something somewhere else. Let me go to a Riyadh or Dubai company and get the data. No, it won't do it automatically, right? They can't basically send email, so they can't say, like while I'm searching for an answer from my tech corp regarding right, my refund policy. I would, the moment I'm asking refund policy, it won't say, hey, you're asking for a refund policy. Let me get that email address of the customer. Let me straight away send an email that this is the refund policy. No, you will still can get that advantage of, right, when you have this MCP in place, right? So while your query can't send emails, update databases, call APIs, or interact with external system, they're brilliant, right, analysts, but they're trapped in read-only world, right? That's where MCP is an emerging standard that gives AI agent a safe, structured access to external tools, right? So that, right, it can bridge the gap between AI reasoning and a real world action, right? So you have in AI reasoning where LLMs have been trained, but then you basically give your real world action, which is transforming your passive assistant into active agent. So the moment someone says, hey, I wanted to understand that what is the corporate policy for taking leaves, right? The AI agent says, that's fine. This is the policy. Can I also document this thing and send it to you on your SharePoint so that tomorrow when you wanted to look into it, you don't have to search again. It will be in your databases in your private repository, right? That is where the MCP comes into, right? They let the models to connect to the query app or data sources, just like in USB, right? Plug and play, right? And this is how MCP defines AIs to talk to tool, share contact, and follow what permissions, right? Who should have permission, who should not have permission, which tools I should be integrated it, and what amount of data should I be sharing to another, right? So email communication, data management, scheduling and workflow, development tools, right? That's where the magic of MCP works. Okay, cool. So LLMs, context window, embeddings, vector databases, RAG, LangChain, LangGraph, MCP. All right, we've learned it so far, right? Now, while there are still a lot of things which I wanted to go through, but what I will do is, okay, so now very quickly, right? Now all of these things are there, right? We basically have a system, but from our side, prompt engineering is something which will basically ensure that you get how good answer you're able to get, right? Now we can go on and on with prompt engineering, but I just wanted to summarize this, that there are bad prompt and there are good prompt, right? Now a bad prompt example is I give a data, everything, and then I tell an LLM or ChatGPT, for example, that summarize this. Okay, so it will give you a vague, unpredictable length of answer, blah 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 blah, because it has summarized this, right? Now a good prompt would be summarize this customer support transcript in 3 bullet points, focusing on customer's main issue, what actions are taken by support, and what resolution status are there. Use a business appropriate language, right? Now with this thing, whatever I'm summarizing, it will tell you this was the customer main issue, this was the action taken by the support team, this was the resolution status, and this is what I'm doing in all of this thing. What I've written is in a business appropriate language, right? So that's where prompt engineering, because end of the day, in our TechCorp, we're still, what we're going to do, the TechCorp would magically not give us answer by just seeing our face or by just reading our mind, right? Maybe that day is also not far, right? But at today, I have all of my TechCorp AI assistant in place, because I know LLM, I know context window, I know tokens, I know RAG, I know MCP, I know LangChain, I know LangGraph. I've made my system in a place that my TechCorp is AI ready, but I still need to basically have a prompt engineering, right, a good understanding of prompt engineering, so that I get the kind of response which is more appropriate and more right, beneficial for my right team, or for my answer, right? And that's where you need to be specific. And prompt engineering these days, there is a certification and there's a course by itself, so I don't want to get into detail, but just quickly, examples are, there are a zero shot method of prompt engineering, where you just classify, you just say classify this email, that's all. And there are few short example. You say classify email as an urgent, okay, or as a routine, because you're giving some clauses there. And then there is right, other classifications where you basically get into detail, right? So there is a zero shot, there is one shot, and then there is a few shot, right? So right, in a very high level, right, I mean, you need to be clearly state what needs to be done. You need to give an example, right, that this is what I'm giving you a background to demonstrate the design pattern. then you basically then you basically go to step by step reasoning. Then you basically give an output format, and then you validate your rules, right? So the analogy which I give is, imagine teaching someone to cook, right? Zero shot is saying make pasta, right? Then they probably know they'll make a pasta. Give an example, give an output, make a pasta. One shot is showing them one meal, right? Make a meal. And few shot is demonstrating several meals, so they can learn from your style. Chain of thought is basically you're walking them through each steps. First boil the water, then do this thing, then do this thing, because the more the reasoning, the more it will make you a better cook, right? How it is important for TechCorp, because mastering this prompt engineering means the AI system gives a consistent, reliable answers to whatever match is there, right? So that's important. What is the use to have a beautiful car when you don't know how to drive? Okay, so far, now putting all these pieces together, what we have done so far, we have explored the technology individually. Okay, so we'll see how it all combines, right? So for example, first thing is document processing. Now TechCorp documents have a chunk of manageable segment, 300 to 500 words. We are converted into embeddings. And the embeddings, what we have used OpenAI's text embedding 3 large model, right? And we have stored that thing into Pinecone vector database. Vector database, we have learned Pinecone is basically one of the way, or one of the right, database method, right? I mean, and then we gave another example as well, right? And then once the documenting processing is done, so far processing part is done, then we do the query part. When an employee asks a question, then where will come, the LangChain will convert it to embedding. Then again, you're doing nothing, it's all happening behind the scene, right? Then it searches the vector database, then it's find top 5 relevant chunks, it retrieves them along with the source and citations, right? Then what happens? Then comes the retrieval augmented generation, RAG augmentation, right? The question is retrieved to the document and combined, carefully crafted, and then it goes to instruct ChatGPT 4 or 5 to answer based on the provided context, and then it gives you a TechCorps communication style answer. Then what happens? Then comes the workflow routing, right? Land graph evaluates the response quality. If it's got high confidence answers are delivered immediately, or if it's got medium answers, or whether it has got flagged for human review because it's not sure that this answer is even good to go without even someone reviewing it, right? And the low confidence queries trigger, then that it will go for additional search with refined terms before trying it again, right? Then what will happen? Then we'll basically do action execution, which is you'll use MCP. The system can automatically send responses via email, log interactions in their CRM, right? Because that's where all the systems are connected. It will do a follow-up ticket for complex issues. It will even schedule meetings if you required. All these while maintaining audit trials for the security perspective, right? For the security purpose, right? Now, system architectural diagram, okay, which is not there here today, but what I wanted to do is from the input layer, your Slack, your email, your API endpoints, or your own prompt engineering, right? Or prompt. Intelligence layer, LangChain, ChatGPT, or GPT-4, LangGraph, prompt templates, which you have already made your existing depending upon your company. Data part, Pinecone Vector DB, MCP tool, logging and monitoring, feedback collection. The analogy for all of these things is each component, what we have learned is like a piece of an Iron Man suit. Okay, the LLM is like an arc reactor providing power. The embeddings and the vector DBs are the sensors gathering intelligence. The RAG is like an AI assistant where it talks to Jarvis, right? You remember all the Iron Man. I don't know how many of people have watched Iron Man movies. So it basically talks to the AI assistant, which is Jarvis, right? That combines information with reasoning, and LangChain is the integrated control system, right? Now, all of these things are basically, right? I mean, with MCP, all of these things they become a weapon and tool, and they become impressive together, and they become unstoppable together, right? What is as a result what we are getting? TechCorp employees get accurate answer in seconds of search within, unlike minutes and hours. Customer support issues are 3 times faster. New hire onboards are in weeks instead of months, and critical systems are learned and improved continuously with a new documented and the feedback mechanism in place. I would not get into the deep of it. It's pretty much the same thing what we went through it. Okay, and then comes the balancing and simplicity part. So, for example, depending upon your use case, you don't have to make things complicated. A great chef knows that the more ingredients doesn't make a meal better. So you have to understand if your use case is simple, then you basically just go with content generation. If you have a medium use case, then bring document Q&A. If you have a complex use case, then have an autonomous support agent, right? It all depends upon, but you basically use the same tools and technologies, LLM, RAG, MCP, LangChain, blah blah blah, so that right, you have all these things in place, right? If you have a simple use case, nothing, just go chat GPT-4, just ask for the prompt, you get the answer. If you have a medium use case where you need to have a RAG in place, then have your LLM embeddings, vector DB, and LangChain in place. If you have a complex use case, then basically you need to have a full stack with LangGraph and MCP in place, right? So this slide is just making right, understand that just because we had all of this stack we have learned doesn't mean that you basically have to use if your problem is simple. Cool. This is what makes AI intelligent, right? So we basically giving us a nutshell, right? Understand thing that LLMs provide a comprehension language, planning, autonomous agents can set goals and determine strategies, learning, memory, action, reasoning, all of these things, right? So this is what AI, all of these things, whatever we have learned so far, that's what makes an AI as an intelligent being, right? Or intelligent thing, right? This is something which basically talks about what next, the future, which is autonomous agents, right? I mean, how to make things more right, better for us by having autonomous agents. Now that is not the right, objective of the class today, but right, we need to understand that right, there is a next step, right? So what happens next? You can basically build up autonomous agents. Maybe that is this is a topic for another day, right? Okay, why we have to learn all of these things? is basically, right, this is important. Millions and billions of people are being laid off because they don't understand AI. They don't understand, the adoption. So we need to know that, right, the 67% of the job posting today, they are, right, more pertaining to the AI skills, which has increased from the LinkedIn data. An average salary is anywhere between 120 to $200,000 for anyone who basically has got understanding of an AI ML skills. There are 3.5 million jobs are created which is newly AI. So just giving an example, right, I mean that if you're not adopting, then probably you are behind, or maybe right, it'll be very difficult with your existing jobs as well, right? Last but not least, right, I mean, with career lift, we have got this AI job ready, 8 to 9 weeks of course, right, which where we'll go on hands on. We'll learn about real tools. We'll understand how things are being project based. We will be completely having a mentor guidance available. We'll basically doing this course not for people to just understand tools and technologies on a high level, but also how it will be job focused, and the curriculum will be designed in a way that what the employees need, right? So it's not a theory only course. It's not a tool tutorials course. It's not a generic AI, right? Just the way you've understood it today. We will give more clarity in all of this topic in details, how to work under the hood, how to develop things on AI, how to give, right, I mean, more clarity on how things have been built using different tools and technologies for AI. All of this thing is something what we will be going into our courses, right? So it's not a book on swimming. We teach by getting you into the pool, right? So we'll basically, right. We say that we are founded with a simple belief that you can't learn to swim by reading about water. Okay, and that's what's been happening today. Everyone is basically buying a course and just reading, and they don't understand anything, right? So we can help you in that. And there's an 8 week job ready AI boot camp, which Samir can send it to you if you need. And yeah, the AI revolution is now. I'll just end up with a Chinese proverb, which means the best time to plant a tree was 20 years ago. The next best time is now, right? So uh, happy to help you in whatever way we can, inshallah. So just share the screen. Cool. Sorry, guys. I mean, I just took 20 more, but Samir, you can stop the screen sharing.